Okay, let's finish off the chapter 5 notes. This is the end of page 11. We're going to continue with this problem we are working on. But we have a population mean of 100 and a standard deviation of 15. And question B says, what is the probability that the mean of the sample of 20 people is between 95 and 105? Okay, so in other words, we're grabbing 20 people. We're going to average their IQs together. What's the probability that we get an average IQ for those 20 people between 95 and 105? When you get to these problems that are between, I would recommend using StatCrunch. I'm going to show you some ways that you can get StatCrunch to help you out. But first, we're going to practice finding those z-scores like that previous problem. So we have two values in this one, 95 and 105. Got to get a z-score for each one. All right, so we got z equals, okay, let's do the 95 first. 95 minus 100, going with that same formula here, right? So 95 is the x bar, mu is 100, and then divided by sigma divided by square root of n. So 15 divided by square root of 20. This is what I'm going to type into my calculator. I'm doing it how I showed you in that last video. Let's see what we get here. So I'm getting a negative 1.49. Okay. Double checking. Yeah, looks pretty good. Okay, now I've got to get another z-score for the 105. So repeat 105 and then still minus 100 divided by 15 divided by square root of n. Okay. So plugging that in. Positive 1.49. Seems to make sense because they're both 5 away from the mean. So this is positive 1.49. Those are the z-scores corresponding to those values. Now I want to find the area on the normal distribution, standard normal distribution, between these two z's. That's when I'll go to StatCrunch. Okay, so let's jump to StatCrunch and see if it can help me get the question right. Okay, let's go to a main page. We're going to that normal calculator, stat, calculator, normal. And then I got to click the between option for this one. Negative 1.49 to positive 1.49. And there's my final answer, 0.8638. Right, so 0.8638 is the probability that we'd have a sample of 20 people have an IQ between 95 and 105. Okay, so that one I did that two-step process, finding that z-score first. Really, this feels very much like 5.2 then. The only difference is you have to do that little funky formula of dividing by the square root of n in the denominator. Remember when we did 5.2, we also played around with changing the mean and the standard deviation to do the super shortcut. You could do that here as well. So this avoids finding the z-score with the z-score formula. If I plug in my mean 100, I just got to be careful with my standard deviation. It's 15 divided by the square root of n, right? So I got to hit divided by. What you can do here is just go SQRT and then parenthesis whatever n is. So in this case, 20. Okay. And so if I'm putting that there, then I have to put just the x values here, the 95 and the 105. And I should get the same answer. And I do 0.863. It's a little off because we had some rounding that we did, right, with those z-scores, right? But still about 86%, okay? So feel free to do it that way as well, but you may want to practice finding those z-scores that could come up in just a question on its own. Okay, so let's try one more of these and see if we've got this. I'm going to do it the StatCrunch way. Oh, I could do both if you guess, if you want. So let me get the handout back up here. So we have some things I'm looking for in this problem. The mean, that's the mu. Standard deviation, that's the sigma. Okay. What's the probability that a randomly selected undergraduate less than 2,700? Okay. So notice how it says, what's the probability that a randomly selected? You know what this is then? This is just 5.2. Because we're not grabbing a group of people, we're grabbing a single person. So I'm just going to do it the 5.2 way, right? At z is, the first value always comes from the question. Next is always the population mean, and then divided by the standard deviation. I could even still go divided by the square root of n, because here the n is 1, right? One taking one person, so square root of 1, don't really need it, right? Dividing by square root of 1, divided by 1 doesn't change it. Okay, so there's my z-score, 2,700 minus 3,173 divided by 1120. So I'm getting about a negative 0.42, approximately negative 0.42. And then I got to change that to an area under the curve. Table, if you like that table, keep going that way, or StatCrunch. I'm going to do, you guessed it, StatCrunch. So let's do back to 0, 1. Okay, and then I want standard for this one. It's less than, so I got the right symbol there, and then negative 0.42 for my final answer of 0.3372. Okay, and then again, that super shortcut, I could have just put the mean and the standard deviation up here. The mean 3173, standard deviation 1120, but then I would just put the 2,700 here. And you get the same thing, close enough, right? Again, rounding error from the previous one. This one's actually more accurate. Okay, and how does this part A differ with the part B, right? So if I look at part B, now I'm going to select 25 undergraduates, right? So it's no longer a single undergraduate, it's 25 undergraduates. So now my z-score is pretty much the same thing. The only change is in that denominator, divided by a square root of 25, okay? All right, so I've got to work on calculating that correctly to get my correct z-score. And I'm coming up with negative 2.11. And then now find the area under the standard normal distribution, just like we did on part A, just with this new z-score, it's less than, so it should be good. Let's try it out. Back to this problem. So since I found the z, I gotta have mean 0, standard deviation 1, and then I'll put the z-score there, negative 2.11, right? I'm getting 0.0175, 0.0175, final answer. Again, the super shortcut, we could put the mean here, the 3173, and the standard deviation 1120, but now since we're taking 25 people, divided by SQRT 25, and then put the 2,700 there. That should be about the same at 0.0173. Okay, so it's really close. A little off again because of the rounding of that z-score. This one's more accurate. Okay, so that's about all I got for 5.4. Give those problems a try. If you have questions, definitely feel free to send them my way. Hope all's well. Bye.